8th graders, lesson 3 in our chapter on earthquakes. This will be the last lesson in quarter 3. So our Mind Planetary is a fun fact called A Whole Lot of Shaking Going On. Is the ground moving under your school? A project that will monitor shaking underneath the entire nation might help you find out. In 2004, scientists in the U.S. Array project placed 400 seismographs across the western United States. Every month, 18 seismographs are picked up and moved east, leapfrogging the other seismographs. The map below shows one arrangement of the array. The seismic data that are obtained will help scientists learn more about our active Earth. So right there is, you can see pretty much all right there in those kind of middle western states. All right, so 2 key questions. How do seismographs work? What patterns do seismographic data reveal? So seismic waves cause a simple seismograph's drum to vibrate, which in turn causes the pen to record the drum's vibrations. So a seismogram is the record of an earthquake's seismic waves produced by a seismograph. But from past seismographic data, geologists have created maps of where earthquakes occur around the world. The maps show that earthquakes often occur along plate boundaries. Earthquake risk in North America largely depends on how close a given location is to a plate boundary. So 2 plates meet along the Pacific coast in California, Washington, and Alaska, causing many faults. Frequent earthquakes occur in California where the Pacific plate and North American plate meet along the San Andreas Fault. A movie about that is called San Andreas. Shows a huge earthquake along the San Andreas Fault. So earthquake risk around the world. So there's the Ring of Fire, which includes the west coast of Central America and the west coast of South America. So strong earthquakes have occurred in countries along those coasts where plates converge. The Pacific plate collides with several other plates across the Pacific Ocean. So the Indo-Australian plate collides with the Eurasian plate, and other earthquakes are common where Eurasian and the Arabian and African plates collide. So here's an example of a seismogram. So you have the earthquake happens at time 0, so you have the background noise, then the P waves, remember we talked about that last week, then time between the S and the P waves. So then here's the S wave, and then the surface waves, okay? And then you have the time down here on the bottom. So a couple other pictures. Here's a seismograph. So this is the frame, this is the fixed mass, the base, and then ground movement here is what moves all of this. Okay, and then lastly, the plates. So we talked about the North American plate. So here's the U.S. So the North American plate along the Pacific plate right here. Okay, and then we talked about the African, Arabian, Eurasian plates, and then the Eurasian, Indian, Indo-Australian or Indian-Australian. And the Pacific plate also is over here. And then there's, like you can see, the Philippine, Caribbean, Cocos, Scotia, Juan de Fuca, all those smaller plates, okay? So one vocab word, seismogram, is the record of an earthquake's seismic waves produced by a seismogram. And your assignment is to complete the unmodal questions for lesson 3. It will be a very short assignment, but let me know if you have any questions, and have a great Tuesday.